Good morning, this is your stat sensei, Mr. Spensei, and we're going to run a hypothesis test. This was our assignment for today. So the national average SAT score is 1006. Somerset High School counselors feel that their students are performing below the national average. The high school counselor has chosen 32 students at random. Good, we have a random sample. And found that their average SAT score was 853. So we have an X bar equal to 80 feet, 853, with a standard deviation, a sample standard deviation of 38, because that came from the sample. Over 600 students at Somerset High School have taken the SAT. All right, that's probably important. For our condition, is there evidence to support the high school's hypothesis that their scores are below the national average at a significance level of 0.01? So that's our alpha. All right, so alpha is 0.01. So our parameter, let mu equal the true population mean SAT score at SHS, Somerset High School. We'll abbreviate that. All right, so our hypothesis, the null, HO, mu equals 1006. That's the national average. That's the claim. Our alternative, we're concerned that it's less than 1006. And we want to know the chance of that happening by random chance alone. Our formula, T equals X bar minus mu S divided by the square root of N. Our conditions, first condition has to be a random sample. Well, in this case, we know it's a random sample of, they chose 32, and that was given. 2, we need N to be less than 10% of the population. Well, in this case, there was 32. We went 32 times 10, and we got 320, and that's less than the 600. So that was taken care of. Number 3 is normality. All right, well, they didn't tell us the distribution was normal, and maybe it is, maybe it's not. SAT scores are, but we don't know about Somerset High Schools. But N is 32. That's greater than or equal to 30. Normal by CLT. Next thing, we need to draw our picture. And our picture is this. We're centered at 1006. But we got an 853. And we're shading down. So this is our X bar, this is our mean. And we weren't given data. All right, we're given statistics, so we really don't even need that. So we're going to go ahead and label our parts. Our mean is the population mean, which is 1006. Our X bar was what we found from our sample, was 853. We had a standard deviation of 38, a sample size of 32, and we're shading less. So now we need to plug into our formula. So our probability that T is less than 853 minus 1006 over 38 divided by the square root of 32. So here we go. Let's run that test. Stat test, t-test. Stats need to be highlighted. Our mean was 1006. Our X bar is 853. Sample size of 38. N is 32. We got a less than, and we press calculate. When we find out, we get a very interesting T statistic. Probability that T is less than negative 22.77. That is a long way from the mean. So we end up getting a p-value of approximately 0. Wow, that hasn't happened. So a p-value of 0, and alpha was 0.01. Well, 0 is definitely less than that, so we're going to reject the null. And what can we say? Our p-value is is, and I'm going to use the approximate symbol, approximately 0. Our decision, we reject the null. There is sufficient evidence at alpha equal 0.01 to suggest that the true population mean SAT score at Somerset High School is less than the population, is less than 1,006. All right. And please remember, all we did was we stated our p-value, which we got here, our decision right there, reject and null. There is sufficient evidence that alpha equal 0.01 to suggest that this came from our parameter, true population mean SAT score at SHS. All right. And this part right here is a restatement less than 1,006. Less than 1,006. A restatement of our alternative. Appreciate you watching. Hope to see you on the next one.